Welcome back everyone. Today I'll be using the properties of determinant to show that it is zero. The question reads as follows. The determinant is given by the following. This is a determinant that I need to show that it's zero, and I'm going to use the properties of determinant to show that it is equal to zero. So in order to do this, I will have to do row operation. Whenever you see 1, 1, 1 or a constant, I always encourage students to get some zeros by doing row operation. Sometimes you do column operation. It depends on where the constants are. In this case, because it's in column 1, I will be getting zeros in row 2 and row 3. So for row 2, my new row 2 will be row 2 minus row 1. And the reason for doing this is getting zeros to assist me in doing my proof. So the first row remain as is. So I have my 1, A, and B plus C. But here, 1 minus 1, that's 0. B minus A, that's B minus A. But for the next part, I'm subtracting. I will be writing it to my right so that you can clearly see what is happening. So I have C plus A minus, and then I have B plus C. Now I'm showing you this because the minus sign affects everything behind. So what we really have is minus B and minus C. So the C's will cancel and I'm left with A minus B. So it will be the same case. We're going to do another row operation. So for row 3 is equal to row 3 minus row 1. Row 3 minus row 1, so 1 minus 1, that's 0. And then C minus A, that's C minus A. And then the next part is going to be the same concept where I have A plus B minus B plus C. And once again, the sign affects everything that falls behind it. So what really happened is that we have a minus B and a minus C. So don't forget the sign affects it. So having this, I see that the B's cancel. So I am left with A minus C. Now look carefully. A minus B can become B minus A by factoring out minus 1. So A minus B, if I factor out negative 1, we have a change of sign. And what's going to happen is that it's going to become B minus A. However, if you're not seeing it this way, I can show in detail. So let me go ahead and show you in detail. Now, I am going to factor out negative 1. So this becomes minus A and plus B. Then rearrange, so I still have the minus 1. So I'd have the B first, and then the minus A second, and there you go, B minus A. So A minus B, I can rewrite it. Just rewriting it, it is still A minus B, but rewritten in a different way. That's all I'm doing, so that we can see B minus A's exists right there. So B plus C, and then here I'm going to rewrite it as minus 1 B minus A. Same scenario here, the A minus C will be minus 1 C minus A, using the same concept. So now we can factor out B minus A and C minus A out of row 2 and row 3 respectively. So factor out B minus A. I will also factor out C minus A. And factor it out, this is what will happen. I'll have 0 and then put 1 as a placeholder here, then -1. So all of this is removed. We don't leave it empty. We put 1 as a placeholder. When we factor out c minus a, we put 1 as a placeholder and then -1. Now having this, I can do row operation. So doing the row operation, which is row 3 equal row 3 minus row 2, I will be able to get all of row 3 to be 0, and this will assist me in getting the determinant to be 0. So I repeat, I'm doing this to get all of row 3 to be 0. So I will write this, and then doing my operation, 0 minus 0, that's 0. 1 minus 1, that's 0. Minus 1 minus 1, that's 0. Having this is having an upper triangle, and the determinant of the leading diagonal will be the determinant of this. So multiplying 1 times 0, that will be 0. So what we have here is b minus a times c minus a times 0, because 1 times 1 times 0 is 0. So multiplying all of this, I will get my determinant to be equal to 0, which is therefore proven. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.